Matthew, maybe it goes back into academic, but I'd be surprised.
Good luck. Thanks.
Stage is yours.
Okay. Thanks. Yeah, I'm Matthew. So yes, unlike the previous talks, I'm not going to talk about real software. I'm going to talk about design proposal that could be real software someday if we feel like it. Yes, so it's a design proposal. It's also really a request for feedback. I'd be interested to hear what you think of this proposal, good, bad, if you have any extra suggestions for how to change it or improve it. You can also treat this talk as just a set of ideas that you might want to use in your own local first projects. So our goal here is to make what I'm calling version collaborative documents, which combine the best features of Google Docs and Git. So on the Google Docs side, we have, of course, real-time collaboration, but also this idea of different document types like Word documents, spreadsheets, recipes, etc. They each have their own custom behaviors. On the Git side, we have version control, diffs, branching workflows where you can fork a document, make some changes, and merge it back in, and of course, local first and decentralized. Then in addition to these features, we'd also like to not have just a fixed like Office suite, but also the ability for programmers to add third-party document types. Like if you figure out how to implement, collaborative CAD files, you should be able to implement that on top of some common platform with a common backend. So to outline this talk, I'll start with the core concepts behind the proposal, which are sort of analogous to the concepts in Git. I'll talk about a platform, which is sort of like the generic backend-ish layer for many kinds of version collaborative documents. Then since it's a programming workshop, how to actually program these different documents, and then with some related work. So our first concept and the central one is a document. A document is just a unit of collaboration, basically a thing that a group of users can collaborate on in real time, analogous to just a Google Doc or a Google Sheet. As you can see kind of in the picture here, we got a group of users who are looking at this document. They can see each other's cursors, make live edits. Oops. There we go. Yeah, so instant local changes in your own document. These are propagated live to collaborators, hopefully within a second or so. Conflict-free merging, if multiple people are making edits at the same time, they should all show up and sort of preserve the user's intent as well as you can. So under the hood, a document would be a document ID, which is just a UUID, labeling a grow-only log of updates, describing the changes to the document by different users. Probably these updates would be just operation-based CRDT messages so that you don't have to worry about like reordering and latency and stuff too much. So pictorially, we've got this document, just a little square here. It's got a document ID, 9B1D, etc. It labels this log of updates, insert some text, delete some text, set the formatting of some span of characters. Then when Bob's working on this document, he'll generate new updates saying, set this span of characters to have font size 20, makes a newer log with this extra update. Likewise, Alice can make her own edits, insert some new text in the document. It just keeps appending to this log. Okay, so our next concept is a fork. So now we make the rule that at any time a user who has read access to a document can make a fork of it. This creates a new document with a new document ID whose initial log copies the original log, sort of like a git branch command. So here in figure form, we've got this document. It's got two updates in it, and this document ID, 9B1D, etc. So Bob, who has read access to this document, can say, I want to make a fork of it. It copies the update log to a new document with a new doc ID and also a new owner. So Bob owns this document, and he has full permissions on it, regardless of what permissions he had on the original doc. So now Alice and Bob can make their edits independently, just appending new updates to their logs. And they may not even be aware of each other's updates. Like maybe Alice doesn't even know that Bob forks this document. So they're just completely independent units. Of course, if you can fork documents, you also want to be able to merge documents later. So here the idea is that if documents A and B have a common ancestor, we say that A's owner is allowed to merge document B into A. And what this does is it copies over the new updates from the other document's log. So in pictures, we've got these two documents from the previous slide. They've each had so they were a fork of each other. They've each had some other updates in the meantime. And now Alice can say, okay, I like Bob's edits. I'd like to merge them into my document. So this makes this appends new updates to her log, which is basically just all the updates that Bob's made that weren't in Alice's document already. So for example, maybe Alice inserted some new text while Bob did some editing and changed some formatting spans. Now when you merge it in, you'll have both of those changes. And the hope is that if we use something like operation-based CRDT messages for the updates, then the result should approximately make sense. Like if you use the paratext algorithm to manage the characters and the formatting spans separately, you'll get the result, which is basically what you expect of like the characters formatted how you said. Of course, this won't always work, so you probably want to have some sort of diff preview view where Alice can look at what changes are Bob's updates going to make to her document before she approves the merge, just like a GitHub pull request. Okay, so those are the concepts. Let's see how you might actually use this fork and merge behavior in practice, like a semi-realistic example. So our setting is that we have at a company, there's some financial analysts on the team. They have this document that they give to the executives saying about what they think the price should be, like the modeled price for their product, and what they model the company's profit will be, and then how it compared to the actual numbers for each quarter. So we have this Q1 report that's owned by the manager of the team. They're the only one who can make updates to it because they want to keep it in a nice state for the executives. So when people want to work on it, they make some forks. So the analysts make a new fork where they can update the model to improve the accuracy. And then also some interns that make a fork where they can enter the new data for the next quarter. So now people make their updates. The analysts edit this document just like in a Google Sheet. They're all live editing the document together, updating the spreadsheet formulas. Likewise for the interns, they open it and they're each typing numbers. They can type over each other, whatever. Then maybe at some point the analysts think that their model is doing well. They want to see how it works on the Q2 data instead of just the Q1 data. They fork off a new document, which we can just call test, merge in the interns' updates, and then you can look at the resulting state. Maybe they say, okay, this model is not perfect. It's giving us some weird results on the new quarter, even though it worked on the previous quarter. Going to make some further updates in our collaborative view. And then once they're ready, they can tell the manager, okay, we're ready to merge these updates into the main document, make a merge request. The manager says, okay, we're good. Likewise with the interns, they say, here's the Q2 numbers, merge them in. And now we get a nice new Q2 report with a better model and also the updated numbers. Okay, so that's just a summary of these concepts. We've got a document, which is a unit of collaboration. You can fork a document, which copies its update log, because documents are really just a log of probably up-based CRDT messages. And then you can merge a document just by copying over the new updates and hoping you get a reasonable result. Okay, so moving on, now let's talk a little bit about the platform, which is sort of the generic implementation of how do you implement a generic version collaborative document, basically just viewing it as its update log. And now we treat the updates as opaque and don't really care what's inside them. So here's what I propose we do. When a document is created, its owner assigns it a home server, which could be something like github.com, GitLab, etc. The home server keeps a copy of the document's update log, which we treat as the single source of truth for the document. So of course, users still have their own copy of the update log, which they update in a local first style. Whenever you make an edit, it updates your own log. You see the change immediately. But these updates are technically just optimistic or tentative until you push them to the home server and the home server says like, okay, yes, you had permission to update that document. So what this looks like, we've got the home server's update log, grandma's update log over here. She inserts some new text into the document, which shows up in her own log, in her own document state immediately. And then at some point she'll push it to the server. The server will say, okay, yes, I approve this update. I will add it to my own copy of the log. And vice versa, when other users make edits, they'll send it to the home server and eventually reach grandma's state. And the fact that these updates are reordered here hopefully shouldn't matter if you're doing some sort of like op-based CRDT or other commutative data structure. In principle, we could also have peer-to-peer updates in this setting. Even though I've said central home server, grandma could still talk to other peers, like people next to her on a train, and get their updates as they're collaborating. So they'll see each other's updates because they're persisting to their local logs, but technically these updates are tentative until you push them to the home server, and the home server says like, yes, that person did indeed have permission to access the document. Okay, so now the question you've been thinking for the last two slides is, hey Matt, this isn't local first, right? You have a home server that's a central source of truth. So I want to try to argue that actually it's okay and we can still get the properties we want most of the time. So yeah, the objection is that a user's update log is not the single source of truth anymore. It's just technically a cache or like optimistic copy of the home server's update log. But the difference from like a traditional client server app is that a user can still fork their local copy of a document, which does create a new local source of truth. And I would argue that this avoids many of the problems that we're worried about in the first place. So first half, you say your home server is down, or maybe they jack up the price, so you don't want to pay them anymore. Well, then you fork a local copy of your document, put it on a different server, and hopefully coordinate with your collaborators to say to them like, hey, please, merge your existing tentative updates into this other copy of the document. We're going to go on collaborating from there. Likewise, if the whole internet is down, you can make a fork on your local device, say I'm the home server now, we can talk peer-to-peer for now, and then later, maybe once we have internet back, we'll fork our document onto a different home server. Likewise, if you lose permissions to a document, like maybe you have some petty dispute with the document's owner, you can just fork the last version you saw. Now you have a new document that you're in charge of. In the same spirit as like a git fork, where if you disagree, or there's some sort of schism, you just make two different copies that work independently from now on. Okay, so the other question is, why put this home server in the first place if it's kind of a compromise? So the reason that I made this choice is because if you go back to the fully decentralized setting, which is like peer-to-peer or no central server, then permissions are really hard. You have all these tricky scenarios like, Alice removes Bob from the document, concurrently Bob makes some updates, maybe other users saw these updates already and made further updates on top of them, and now you want to know, okay, were those updates valid or not? Should I reject them, like take them out of my current state? Or, are they even, which ones are valid? Likewise, there's scenarios like, Charlie and Dave are admins on a document, they both ban each other. Now you have to make some CRDT-ish decision about what the final state is, while keeping in mind that, the removed actors might not be trustworthy. It's just, I don't know, it seems very tricky. So the home server lets us say, we'll just use some simple centralized solution, like, the server has its own database of who's allowed to access the document, and it'll just accept or reject updates depending on its state at the time of receipt. It's like when you receive an update, you'll say, was it allowed or not? Okay, so that was the platform. So now I want to talk about the programming part of programming Logo first. So how do we actually implement, version collaborative spreadsheets or recipes or CAD files on top of these update logs? So we need three things. We need a schema for updates saying what they mean. So we might say like, okay, each update is a YGS operation. You need a renderer that takes the update log and displays the actual resulting state in a GUI to the user, and also generates new updates in response to user input. This could be, for example, if you've used like one of YGS's rich text bindings, basically a wrapper around that binding that then also handles the updates between the YGS state. And I won't talk about it, but we'd also like this diff merge preview view so you know what you're doing before you merge in a different document. So the important part here is this renderer, which is probably familiar to people who have made CRDT-based apps before. So we have these update logs over here, your local copy, and then you just you send the updates to some CRDT state if you're using app-based CRDT messages. That computes what the current underlying state is. You render that in a GUI using some like functional reactive programming framework. The user sees it, and then when they make new edits, it goes back into the CRDT state, which updates the GUI locally, and also the local update log, which eventually reaches the server. So I say familiar, this is very similar to a figure in the Pushpin paper, where they call it document functional reactive programming. Okay, so that's it for the technical content. I just want to mention some prior work, especially since I know a lot of the authors are in the room here. So the main inspiration for this proposal is Upwelling by Ray McKelvey and others at Ink and Switch. They talk about basically a rich text version of this, like your rich text editor where you can fork off documents, make your own changes, and merge them back in later. So the proposal is sort of trying to generalize that to arbitrary update types and document types. There's also Pushpin, which has this idea of document functional reactive programming centered around CRDT documents that you identify by a UUID. And there's also platforms like Matrix CRDT, which Yusuf just mentioned, or AutoMerge Repo, which basically try to be the back-end data stores for your CRDT documents, give them the documents in a nice way that you can read and update. So as far as I'm aware, these don't have forking or merging, although maybe that'll change in the future. And another difference is that they're focusing on the more decentralized or federated setting, as opposed to accepting these home servers as a compromise. Okay, this is just a brief recap of the proposal. I'm interested to hear if you have any feedback, even if it's just like, this is a bad idea, ideas, improvement advice, or how you would go about implementing this. Thanks. Peter's had his head hand up for a while.
So Peter was first. Peter probably wants to explain why this is not allowed first. So maybe let's go with
I think we're sorry.
They all raise hands at the same time.
Oh, thank you. I think this is a great direction to be thinking about. So one of the main examples that motivates this is the use of spreadsheets, obviously, and I think you were kind of using that in your example. But the actual use of variant spreadsheets is merging doesn't really happen, right? You get these forks and you cherry pick changes across them. Mm-hmm. Right, and you never sync back together. So how do you handle this sort of cherry picking workflow?
Let's see, that's a good question. So I thought about this a bit from the CRDT side of how would you handle cherry picking like op-based messages in a CRDT, which there's sort of tricky technical issues around like you're missing some prior updates that probably you said were causal dependencies and you want to preserve those. Yeah, so that's one question. I guess the other one is in terms of like, how do you represent this in a GUI? I have not thought about that at all, but it seems like you should be able to have some sort of history view of like, or maybe like a way to just, outline a grid of cells, say copy these changes only. But yeah, I think that would be neat.
So I want to just quickly get a mood of the room on this manual merging. Do you think like involving the user and helping to make good merges is a great idea? Or do you think that, no, the user should never ever have to manually like be involved in the merging process? What's the thing?
User agency.
So nearly everyone is on users should, like, manual merging is a good idea.
Yeah, on developers, we're biased.
I asked the room, not the general public. Thank you. Further questions? Yeah.
Great presentation. I love that you're thinking about these things. We've thought a little bit about this fork merge model as well. Two thoughts, one on access control and the other on the home server concept. Mm-hmm. I'll start in the reverse order. So home server, at Vision, we had done something similar for a really long time, but we didn't frame it as the single source of truth. We framed it as a discovery mechanism or broadcast, right? So it is the fallback for if you don't have peer-to-peer connection to get up to date really quickly at a known place. It's basically a rendezvous, right, to get there. Mm-hmm. I understand that you're also trying to do that so that you have a source of truth around the access control, right? And so you gave this example. What happens if Alice ejects Bob, and then there were a bunch of concurrent writes? I agree, it's a tricky situation, right, because you don't have consensus. One technique that we developed at Vision is something called submarine sealing. It's basically cryptographic anchoring, but without a logically centralized server. I can go through the details with you after, but the basic idea is as people are making their updates locally, they can decide to take updates from other people under their own authority as well and say, like, I certify this because it's in my causal history. So that's one way to solve it.
Okay, yeah, it sounds like a good idea.
Two very quick points. I won't argue with the home server thing. I think you already have a sense of what I think there. But I think, number one, identifying the diff and merge as actually vital and essential for all local first applications, I think is a very good distillation of something that's becoming clearer to me as we're going further. Mm-hmm. Actually, Brooke's thing about pacalc is like latency is the same thing as partition, is the same thing as working offline, is the same thing as having privacy. It's just different degrees of latency and whether or not you're doing it on purpose, which is meaningful. But the end result is then you need to figure out what went wrong and when now you come back together. So I thought that was a really good insight. And I think it's a hard problem, and I would love to see, like, what should the API be? What are the primitives like that everyone's going to need to implement for the renderers? Or like this is stuff that we're thinking about. I can't wait to see what you do with it. And the other thing I wanted to say was we do have fork and merge in AutoMerge and in AutoMerge repo, and I'm sure you could do it in YJS with a few lines of code as well. It's there. We just hadn't shown it off much lately, so it works. Yep. I can show you on my laptop if you want to see it.
Yeah, I know also, so I think after writing the report for this, before making the slides, I had seen some stuff about like auto merges internals as an update log. It's like, oh yes, this seems very similar.
Did you compare your model with the one that Word, actually, like Microsoft Word, already kind of comes with? So, I mean, talking to non-programming people, they are typically very fond of, sharing documents, merging conflicting views, and so on. And it seems to work, so they really love it. What I'm a bit curious about is how would the experience be different with using something like the home server setup that you have? Isn't this increasing the complexity for normal users too much? I mean, right now they, just send a document, merge it, and they're done.
Yeah, I think so. The home server part is mostly about the live collaboration, like when you have your fork of a document and you want to collaborate on it with several other people. Yeah, I guess it doesn't fit very well into the more traditional, like email a file around and look at the changes and merge it model. I'm not sure how you would make that compatible, other than just like declaring the home server as my device because I'm the only one making updates. So,
I mean, Word has that thing where you can merge documents together, right? So you don't need to manually go through that.
Yeah.
And this looks just very similar. So, I mean, if I would like to sell this to people, what would be the major selling point from?
Business model.
Yeah. Let's see. I mean, I guess for me, the selling point is being able to support different kinds of documents on top of a single platform. Like you want to be able to say, like a programmer can add their new, like, fun little recipe editor, as opposed to just Word documents. Yeah, I guess in terms of Word specifically, the main difference might be like different semantics in terms of merging. Like I know the Microsoft Word track changes isn't really exact in terms of where you're putting characters or not. I imagine that usually doesn't matter if you're like editing different paragraphs. So maybe that's not too.
What I would hope for as a user is to get a view of what I'm actually merging from whom, kind of so have the history. And I guess this is something that you can provide because this is the feature that I always miss if I get Word documents to merge with because I have no clue what the history is, where it came from, where the fork happened, and what merges were done on the way.
Yes, that's a good point.
So Willard, I think you also had a question.
No, it vanished, sorry.
Sorry about that. We had some questions in the back. Are they still?
Hi, thanks for your presentation. Quick disclaimer, I work on a startup that's basically building this for rich text documents, and we have a similar setup with a centralized server for a few different reasons, but permission control is one of them. And just a quick comment on user agency. From our research, we realized it was really important for users to actually see things before they merge, because sometimes the results they would get from the CRDT merges weren't exactly what they would expect. So even if the CRDT merge is good enough, it was important for them to understand, especially with large documents, to understand exactly what was going on and what were the differences as a review step as well from their own work. Was diffing and merging was a really important thing for us.
Thank you. This is great work. So I'm totally on board with the forking and merging. I think that's great. I think having the home server do centralized access control while having still local first document data, I think is a reasonable pragmatic compromise. I kind of hope we can maybe get the decentralized access control working, give it some more time as well. But the point I'm most concerned about is the append-only log of updates, because if it's, say it's a text document and every single keystroke in the editing history becomes a separate update, you quickly end up with a log that's hundreds of thousands of updates long, and now downloading that entire log and storing that entire log are both kind of inefficient. So what we've doing with auto-merge, and which I feel like this sort of fundamental model here would need as well, is some sort of compaction mechanism where you can say, like, I'm going to take these 10,000 records in the log and compact them into something denser so that you don't have to download as many small individual updates. But that does kind of complicate the model because it's not just copying records from one log to another. You kind of have to have some concept of this compressed record replaces this list of individual records that was there previously. I don't know, have you thought about that any further?
Yeah, only a tiny bit. Yeah, I guess one idea was thinking about like the VS Code live share model. of you have your local Git repository that you commit to slowly, and then if you want, you can live collaborate with some people. So like the live collaboration is like, of course, up-based CRDTs, but if you want, you could wait till you commit to say, okay, now I'm going to generate a small delta of exactly the changes that are still relevant, including compaction, and put that in the actual like home server update log.
We're doing this.
Cool.
Yeah, it's badging. It's good.
So now Ronald's question is back.
Yeah, thanks, Martin, for reviving my question. So thanks for the great presentation. You're using basically a referee model. So home server is a referee. You can move around the referee, which is cool because that deals with failure. If you have a referee, you can also use it to basically force the same order of the operations in the log on everyone, if you wanted to, which would solve the problem that Martin just mentioned. So the home server can say, okay, the first 10,000 entries in the log are exactly these operations, and now I can compress them, I can flatten them, because I have the authority, because I'm the referee. So this to me sounds like a very interesting thing to follow up on.
Yes, yeah, that makes sense. Yeah, I guess this notion of like the referee can enforce causal stability, so like there are no more concurrent updates because I said so. So then you can, yeah, like in the pure op-based CRDTs work, just replace it with a state.
Two answers to that?
Yeah, I'm working on a similar system to this, and like that it's peer-to-peer based instead of client server. And I think one of the advantages of building applications on top of this, which I've been building for like the last 6 months, is that with just thinking about everything as a peer is an enormous simplification for the end user developer. So like the DX just feels really good to not have to think, well, this runs on the server, this runs on the client. And so I think his point about the referee, thinking of just think of peers that have different privileges. And that's actually how we implement some of our features. Like to compress the log, for example, we have epochs where you can like freeze state at a certain state and just throw away all previous changes. Obviously, it's a really destructive action, and you'd want to do compaction, which would be smarter. But pragmatically, it's just like let's just compress it all down. And so what we've done with that is like only one of the peers in the space has the privilege of executing that compaction. That way you don't have two compactions going on at the same time and stuff like that. So there's like pragmatic approaches here that you can take that are in the direction of where you want to go without introducing like the home server.
Just a very short summary. I think having a single writer for some state is an amazing way to have easy merges, right? Because single writer, single authority. And it doesn't have to be a central server. It can just be one of the peers, as you said.
Great hustle, Christian. Matt, this compaction history hiding thing, one thing I am really glad to see that you and the other folks in the more academic side are thinking about is this problem. All of the formal literature we have assumes convergence and merging of everything. And like history hiding, you're starting to say like, oh, well, we want to have like a provably equivalent log that skips over intermediate states. But I might have part of the log, so I can, you and I were collaborating, and then I close my laptop, and then you realize we pasted the AWS key into the document, so you do a commit that like jumps ahead, or maybe the one we push to GitHub or to our, the code sharing, put the patch up on whatever. Like I might have a different history that's partially equivalent. You might be willing to send me the full history. You're my lawyer, and we're negotiating, but the version we send to the counterparty with the red lines is going to be like, just the shortcut. So I think there's a lot of really interesting cases here around, and cherry picking as well, right? Like I think cherry picking and history hiding are actually two versions of the same thing, which is we're trying to get more fine-grained control over the dependencies in the history and being able to create different versions of commits that have the same outcomes. And right now this just feels like the Wild West to me as I'm like out there implementing. I have no theoretical framework for what's like, am I just gonna blow my foot off if I try and implement this, or is it totally fine and it's all going to work? We're just making it up as we go along. But we know we do this all the time as developers with rebase, but Git doesn't help. Git's just like, oh yeah, those are new commits. Did you already push those commits? Too bad. But it's the same commit. No, it's not. Something happened somewhere, so it's a whole new set of commits, and anybody who depended on the old ones is wrong. So I think we can do better, but I don't know what to do. I'm really hoping that some of the like theory people will start working on this so that I can implement it for you later.
Did you ever look into delta state RDTs?
Did I look into delta state RDTs? I have seen the paper go by. I looked at it, maybe I didn't read closely enough. I was like, this doesn't feel like it solves that problem. Like it felt like a reiteration of the stuff that we already have.
There's a reading group reading that paper together on
There's
the
a-
local first web dev next week.
There's a reading group reading this on the local first web dev next week. Did anybody already read it and can tell me if it solves that problem? Matthew?
Yeah, I think that's more on the optimization side
Yeah,
of
that's
how
what I
do you
thought.
manage a counter with missing deltas. They don't talk about the problem like how do you manage a text CRDT where you've omitted one of the deltas that tells you how to position future characters.
One thought I've had about this since Brooke is here is that I think this is a problem where we need both like convergence CRDT thinking people, but we also will need cryptography people because we're like the Byzantine failure models where we're using like hashes to like show that we have consistency and coherence. Those hashes then encode some version of the information that we're now eliding. So something salt, this is where I'm out of my depth. Yes, content addressable stuff is just another way of like giving away the keys, yeah.
Yeah,
Brooke, what do we do?
Yeah, I'd say also, I think if you solve this like cherry picking history hiding problem, it also addresses exact undo or selective undo and like reject changes. You could probably build those in at a lower level so you don't have to build it into each individual application.
So just to restate your question, how do I remove stuff from history and still preserve hashes?
Or if I have the full history of like an edit session that has some information I don't want to share with somebody else, and then they make edits on top of like the rebased version that doesn't have that, can we continue to collaborate where I have like a fuller history than other people, right? Like there's going to be different versions of the history. They're sharing some versions, I'm getting versions, like we might all have different levels of fidelity. Is there some way that we can maintain like this Byzantine fault tolerance properties that we have without leaking everything through side channels?
So the short answer is yes. When we were doing the Rhizome work, we looked at this pretty closely. Like, how do I give the comment you made earlier that latency and encryption are effectively the same thing, right? So you can have regions that only certain or regions of the causal graph that only certain people can see, right? A metaphor for that is you take a blank node in the graph, and then you hang off of that. Here's a bunch of encrypted stuff or stuff that I'm not going to push over the wire. But then you can still say, well, I'm doing writes over that, but I can't see all of this stuff, right? So that's one way of doing it. To do compaction with this, you can basically keep a link, so the compacted state with a link to the previous compacted state, and then links to the head of the uncompacted thing. So you have the full history, the compacted state pointing at it.
Let's get a whiteboard later.
Yeah. And you don't have to make the entire history available, as long as it's stored somewhere that somebody can check. Yeah.
I guess this is a great time to leave you to lunch, because I think we're already 10 minutes past our time. So thank you everyone for staying, and thanks for the speaker.